I'm really honored to be at the table with these three folks because, you know, we have in our 90 or so person division here, and really we have in the business line 110 or so FTE, full-time equivalent folks, that many of those are experts within their respective areas of review that they do for us, whether it be thermal containment or criticality. But these three folks, I tell you, they have such a great background and they've learned so much. I don't think any of them are engineers, but they know a lot about our business, and they've really done a great job to educate themselves, and they're movers and shakers within their respective areas of that they work in. So I want to say thank you all three for coming. It's important to us. It's important to us as an agency. It's important to me as leading this business area within the NRC that we not only communicate of who we are and what we do, why we do it, how we do it, but we really listen to folks like yourselves and listen to your perspectives because you have so much to offer us. It can be a situation where we're stuck as engineers into thinking certain ways, and you help us to think outside the box in many different ways. So please continue, and Donna's very good at this, continue to challenge us, but keep doing so because it is important to us to think more on our position. So our first speaker is Donna Gilmore. She's the founder of San Onofre Safety. You can find them at sanonofresafety.org. It's an organization that provides factual government and scientific information on the serious safety issues found at the San Onofre Nuclear Generating Station in San Clemente, California. Since the closure of the reactors at SONGS, San Onofre Nuclear Generating Station, the focus of the organization has turned from operational safety issues to issues of nuclear dry cask storage. Their website, which I just gave you, sanonofresafety.org, is used around the world by journalists, engineers, elected officials, and the general public for credible sourced information on nuclear safety issues. Recent publications by Donna include High Burn-Up Nuclear Fuel, Pushing the Safety Envelope in January 2014, which was co-authored with nuclear physicist Dr. Marvin Resnikoff, who we talked with several times as well here. Diablo Canyon, Conditions for Stress Corrosion Cracking in 2 years, October 23rd, 2014, and San Onofre Dry Cask Storage Issues, September 23rd, 2014. She has over 30 years of experience in information technology project management, including the design and implementation of major technology systems for the state of California and the management of a large engineering data center. So please welcome Donna.
I've gotten interested in this when I heard San Onofre was firing employees for reporting safety problems, and I decided to look into this. And we don't have time to go into all that background, but I haven't been doing this very long, but I've been finding information that I'm very concerned about, and I feel these issues need to be resolved sooner rather than later. The game changer here is this indefinite storage decision on site. It's time to step back and look at things in a whole nother way than the way it's currently being done, okay? In researching the current thin canisters that we use, these are the welded steel ones, I learned from attending the Darrell Dunn NRC presentation that there's no current technology that can inspect or repair adequately these canisters, and the NRC is giving them 5 years to come up with a way to inspect them for cracking and corrosion and other things. But there's no solution for preparing canisters that have spent fuel in them. There's other technology for stainless steel repairs, but not in dry storage canisters. And there is no early warning system. We have somebody that walks around periodically and checks the canisters to see if they're leaking radiation. So I'm very concerned. And the urgency here is Edison, Southern California Edison, that manages the plant, plans to spend $400 million, anytime soon, as soon as I suppose they can get some approval, for about 100 canisters of the thin, what I call the thin canister type, which I don't think will hold up for long storage. So NRC is planning to revise their new Reg 1927 to deal with aging issues, but not until spring 2015. So if you could slow down Edison to not buy anything until we get that done, that would be great, Mark. So anything you can do there, okay? The NRC's aging management plan, let me know, Mark, if this has changed from the technical sessions I attended. The first inspection will be after the canister's 25 years old. 5 of those years are to give the industry time to develop a way to inspect those thin canisters while they're sitting inside the thick overpacks. They're only requiring the inspection of one canister, and we're just talking about the outside of the canister, just one canister at the plant. And then that same canister would be inspected every 5 years. Okay, and then this was interesting. They plan to allow up to a 75% through-wall crack of that canister. And my question that has been unanswered is, I know that when you do seismic evaluations, they're done on intact materials. So now we have a canister that could be cracked up to 75%. In their technical specifications, I'm not aware that there's any seismic evaluation of that condition. So. Now, in January, a 2-year-old Diablo Canyon canister showed conditions for cracking. The temperature was low enough for the humidity and salt to, coalesce, or whatever the proper word is. Deliquesce, melt or dissolve, whatever, on the canister. And that was only 2 years, okay? So that means you have conditions for corrosion which can lead to crack initiation potentially in a 2-year time period. If I have some of my interpretations incorrect, please let me know. I took a look at what else is out there on the market, and the only other thing I see are these thick casks. One is the Arriva TN series, which they're about, 8 or 9 inches thick, forged steel, and then there's the ductile cast iron technology. They're all bolted up to 20 inches thick. And the thick what I refer to as the thick canisters, they are not subject to the cracking as the thin ones are. You can repair them. Well, 20 inches thick, I don't think you have to worry about the monolithic ductile cast iron having problems, but you can replace seals, so there's some repairableness there. You have the ability to inspect the outside because you don't need that extra concrete that protects from the gamma and neutrons. The thick canister does the full protection for radiation. No early warning monitoring system. The bolted canisters have a pressure. There's pressure in the lid, and a change indicates there may be like a helium leak, so you may have to change the seal or something. ASME certification. The casks themselves, the thin canisters, the thin ones, the canisters themselves do not have ASME certification for storage or transportation. Maybe the facility might, but the canister doesn't. The bolted, the thicker canisters have ASME certification and international certifications for storage and transport. And the dispense in depth, we'll talk about it later, but that's also an issue. This is a picture of a Castor V19 as an example. They use an epoxy on the outside. And I'm not going to go through the whole list. These slides are available. I put more detail in the slides than I plan to cover, so that you don't need to hear me talking to understand the slides. I did need to make one point. The thick German canister is not currently licensed in the United States. None of the utilities would buy a canister that cost more money. So because they couldn't get business in the United States, they didn't apply for a license. The licensing process is, according to Mark, is 18 to 30 months. It means a lot of money for a vendor. They wouldn't have priority because they didn't have a customer. So it's pointless for a vendor to get a license unless they have a customer. So any of you that are utilities, if you want to consider the other technology, I've convinced the German company to talk to you and, maybe bid. So if you're interested in something that's designed for more longer-term storage. Okay. All right. There's been this myth that the thick ductile cast iron canisters are subject to cracking or being brittle. There's a Sandia Lab study that states they actually perform in an exemplary manner. They actually exceed a number of NRC requirements. You can look at that later. Let's move on. Most of other countries, they use the thick casts. They put them in buildings. We leave them out exposed. So this gives you additional protection from environment and other external factors. That's just a picture. You can see what they look like. Now, overall, I think I've already pretty much gone into most of these, so we'll just skip that one. Okay, and I've said there's no seismic rating, no repair. There's more details on these slides to back up the reasons I'm saying this, but let's go on. They're not designed to be replaced, as Mr. Boyle said. That's why they're using the bolted canisters in their tests. They were never intended to be replaced, but now we're stuck with these things, and we're probably going to have to replace them in 30 years, 40 years, whatever the time frame is. So that's a problem. And in the canisters, whether you're talking bolted or welded, if there's a failure where the canister needs to be unloaded, right now the only way you can do that is if you have a pool. Well, the NRC allows nuclear plants, after they've unloaded the fuel out of the pool for decommissioning, they allow them to destroy the pool. So they've destroyed the only way we have to replace a canister if there's a problem, from aging or whatever. Right now in California, we have Rancho Seco, Humboldt Bay. They have canisters. They don't have a pool. If anything goes wrong there, what happens, Mark? What happens if something goes wrong and those things crack open and there's no pool? What's going to happen?
Well, initially, we actually, through the Aging Management Program, we detect any cracking ahead of time.
You don't have any technology to detect cracks?
Well, there are technologies that can be used to detect cracks.
Not in spent fuel canisters.
They are, there was I think
That's why you've given them 5 years to come up with something.
Okay.
Okay.
There is a response to that, but we don't have enough time to go through the details.
Right. Okay. On the defense in depth issue, as was said earlier, I think by one of the EPRI speakers and other speakers, the defense in depth, the first line is the thin canister, 1/2 inch, 5/8 inch canister. The second line is the zirconium-clad fuel. So if that fuel is not intact, you have damaged fuel assemblies, and you put it in a can, you're not getting that back because you've got vent holes on the ends of that can. In the German canister, they seal their damaged fuel, either the rod level or the fuel assembly level, depending on the damage, in totally sealed cans. So you do have a replacement for that defense in depth. Okay, and recommendations. We need you to do something now before Edison spends all that money, okay? Somehow, directly, indirectly, freeze procurement of that till we can get this settled. Set higher storage standards. Now we have this extended storage requirement. We need you to take the leadership role to raise the standards. Don't worry about what we have now, what everybody owns. We have to think in terms of what we need. What's in your hand is the future of California, the future of everybody else's state. So this is not the time to, how did I put it, play bureaucratic roulette with the future of the United States here, or of California. We need to step back from all the, bureaucratic thing and really look with fresh eyes that we have a whole different problem here. And your standards needs to be raised, not lowered based on the limitations of the thin canister design. Take a look internationally, what's out on the market, evaluate them, based on what I've read and people I've talked to, engineers, physicists, it appears to be a better technology that might buy us quite a few more years, okay? And then to the utilities, please take this serious. Please step out of the box. The prices have changed. The price of metals has changed. The German design may be much more competitively priced, but we won't know until we can find a customer that will seriously allow them to bid. If you go to San Onofre safety.org or you get a copy of these slides, all the things that I have on these links are documents with 10 zillion more resources from NRC government documents, EPRI documents, labs, backing up everything I have in this presentation. Okay, there's this myth about the Fukushima canisters held up Therefore, ours will hold up. Well, they used the thick bolted lid canisters at Fukushima. They did not have high burnup fuel. This is a picture of where the Fukushima casks were stored. This is a before picture, not an after picture. So they were housed in this facility, totally different than what we have. So anybody that says, oh, well, the casks held up in Fukushima, therefore we're okay, totally different, oranges and apples. This is a picture, a graph I got out of, I forget which technical document, but you can see from this, when you start going into high burnup fuel, you start having more cladding failures. You get up in the mid-30s, you can see the trend, it kind of shoots up and you get more oxide thickness on there, which is an indication of a problem. Now, I think Bob will probably at some point want to make a comment on this, or maybe you and I can
make it right now.
Not no. Let's say what I'd like to do is talk to you offline, and then we and deal with that. But this is an indication of something, and maybe Bob, you and I can talk afterwards, and we can come to some center on this. This is just a slide that was that Daryl had presented at one of his meetings, talking about the conditions needed for cracking, and that there were other types of components that had cracking within 11 to 33 years where the item had to be taken out of service. Just go on. These are actual examples where they had through-wall cracking of other components. You can look at that later. That's just a picture of all the things we don't know. This is a DOE slide showing just areas of things that we do not know about dye canisters. So saying that we have all this confidence, I kind of wonder. It's San Onofre. This is the kind of cesium we've got. To the left, you see how much cesium there is in a 10 megaton weapon. The last three bars on the right are the cesium that we have at San Onofre. So our concern in Southern California is we want to have the best, we deserve the best on the market to protect us as best as possible. Maybe Bob will think it's overkill, but what's the future of California worth? And the wind blows east. You're talking about our food supply. You're talking about we have 40% of the import-export cargoes for the whole country. You're talking about devastation of California. You're talking about devastation of the national economy, which is going to affect the initial economy. You know, what kind of price are you going to put on that? Okay, this is our unique problem at San Onofre. You other nuclear plants are doing a much better job here. This is a slide of plants that are currently in decommissioning status. And this slide represents the number of safety complaints from employees to the NRC regarding problems at San Onofre. You can see we're a special case here compared to the rest of you. The rest of you are doing a much better job. Okay, I attended a session where they talked about approving M5 for St. Lucie Unit 2. M5 is a new improved, quote unquote, zirconium cladding. This slide shows in storage that both the new improved Zerlo and M5 have more problems than the Zircalo 4 they were using before. And when I brought this up in that NRC meeting, they said, well, it works better in the reactor, and the fuel issue is like somebody else's issue. So this idea that you can approve fuel in the reactor and only look at how it works there without looking at what happens when you flush it down the toilet and give it to us in dry storage. To me, those things should be together. You shouldn't be approving new fuels until you know how it operates in storage. This is what is causing all this problems we have. Okay, well, that's it. That's all I've got.